So this video is Integrated 1, Chapter 9, D-Day number 2. So on these first problems, what you want to remember is that on these, all of these are not absolute value equations or inequalities. So you should not be trying to work out two different situations. You should only be getting one boundary point. These ones down here, that's an absolute value equation. You're going to work out two of them. This is an absolute value inequality. You're going to work out two of them. This is where you're going to have two situations, not in the first ones, only where you have the absolute value symbols. And when I'm talking about absolute value symbols, I'm talking about those are absolute value symbols. These are absolute value symbols. Only those ones will you have two equations that we're going to be working out. Okay, so on these first ones, what we want to remember is when we're solving an inequality as an inequality, the only time you're going to switch the direction of the inequality is if you multiply or divide by a negative. So I'm just going to draw it up here. Multiply / divide by a negative number means you're going to switch the inequality direction. Otherwise, the inequality is going to remain as is when you add, subtract, or multiply and divide by a positive number. So on number 1 here, first thing I'm going to do is add 2 to both sides. I get 7x is less than 28. We're going to divide by 7, and we get x is less than 4. That is going to be our solution. And when we are doing this on our number line graph, I want to put 4 here because that's my boundary point. It's going to be an open circle because there is no equal underneath my inequality. And then this is x is less than. So I am going to be shading to the left. That is my graph, and that is my solution. On number 2, on this one, just be careful. The x is on the other side, which is okay, but you just want to think about it when you're giving an answer. I'm going to add 12 to both sides. I end up getting 30 is less than or equal to 6x. I'm going to divide by 6, and I get 5 is less than or equal to x. So 5 is less than or equal to x. Some of us might want to rewrite this and have the x on this side. And if that's the case, then the inequality direction is going to be switched. Those are the same answer. Okay. Now, for it in this form right here, again, 5 is our boundary point. It is going to be a closed circle. So I want to see the closed circle because of the equal underneath. And if you're looking at it this way, this is saying 5 is less than or equal to x. And what we're trying to do is graph our x. So if 5 is less than or equal to x, 5 is smaller than or equal to x, then what's x? Well, x is going to be greater than the 5. So we're going to be shading that direction. Okay. Now you probably understand it when you are seeing it in this form here, but both of these are the same. These are both the same. On number 3, so this one, we have x back on the left-hand side. Okay. And what we're going to do is we are going to minus 5. When we do, we want to be careful. That's a negative 4x or a minus 4x, less than or equal to 12. Now I'm going to divide by a negative 4. I'm going to divide by a negative 4. And remember, when you divide by a negative, you're going to switch the inequality direction. So I am going to end up getting x is greater than or equal to -3. So we want to pay attention to this got changed to this. And our answer is going to be x is greater than or equal to -3. I'm going to have a closed circle at -3, and I'm going to be shading to the right. Okay. And that's going to be our graph. Now on 4, we have x's and numbers on both sides. I personally like to deal with my x's first. So I'm going to add 8x. I'm going to add 8x. And what's going to happen is my x's are going to cancel out. But let's see what I have. I get left with a 10 is greater than or equal to 15. You want to ask yourself if this is a true statement or a false statement. So if true, then that means all real numbers is your answer. If false, that means no solution is your answer. So is 10 greater than or equal to 15? That is false. So we're going to have a blank graph, and our answer is going to be no solution. Now, number 5, this is an absolute value equation. So I'm going to write 2x minus 3 is equal to 13. But 2x minus 3 could have also been a -13 because the absolute value of 13 and -13 is both 13. I'm going to add 3 to both sides here. I get 2x is equal to 16, divide by 2, and I get x is equal to 8. So that's going to be one answer. Over here, I'm going to add 3 to both sides. I get 2x is equal to -10. I divide by 2. And I get x is equal to -5. That's another answer. So we're going to have x is equal to 8, x is equal to -5. We're going to have two solutions. And this is an equation, so we're not going to have to draw it on a number line. Now, 6 is an absolute value inequality. So on this one, I'm going to think of it as an equation, okay? And I'm going to solve it to find my two boundary points. So I'm going to work out x minus 4 is equal to 10. And x minus 4 could have also been a -10. I add 4 to both sides. I get x is equal to 14. I add 4 to both sides. And I get x is equal to -6. So I have at -6 and I have at 14. Now I'm looking back at the original inequality. It is strictly greater than. So that means I'm going to have an open circle at -6 and 14. And either I'm going to shade in between or I'm going to shade out. So one way to do it is to substitute in a number. So let's say I try 0, and 0 is in between the -6 and the 14. So if I was to try 0 into the original inequality, so 0 minus 4 in absolute value greater than 10. Absolute value of -4 greater than 10. Well, that is going to be 4 greater than 10, which is false. So if it's false here, that means it's going to be true outside. So then we can shade out and out. Another way to think about it is what's happening here is this x minus 4 would make that 0. So the center of these two numbers, -6 and 14, would be 4. And this is 10 away and this is 10 away. But we want it to be greater than 10 away, more than 10 away. So if I want it more than 10, I'm going to be shading out like I have in the picture. If it was less than, I'd be shading less than 10, and I would be shading where it says false. Okay, that's another way to think about it. Okay. So you don't have to write the word false there. I just want you to understand that that was false. 0 made it false, and 0 was in between. And I erased my numbers here. Sorry, this was a -6 and this was a 14. So how do I write my answer? When you have two separate pieces of graph, I'm going to define each of them. So the first one I'm defining, I'm just going to shade for a second. I'm going to define just that piece. So that piece right there is going to be x is less than -6. And then I need the word or. And then the other piece over here is going to be x is greater than 14. So x is greater than 14. So I need the word or in between. On number 7, I'm going to graph this on XY axis. Do not decide if you're going to shade above or below until you get your y isolated. So I'm going to subtract 2x from both sides. I'm going to get -4y is greater than or equal to, and I'm going to write the -2x first and then plus 12. Then I'm going to divide by -4, divide by -4, divide by -4. Remember, when you divide by a negative, you need to switch inequality. So what that means is now I am going to get y, and instead of it being greater than or equal to, now it's going to be less than or equal to. And then I am going to have y is less than or equal to 1/2 x, if I do that math, -3. So for this, I'm going to have a y-intercept at -3 because that's the constant. Then my slope is a 1/2, which means I'm going to go up 1, right 2. So from here, I'm going to go up 1, right 2, and I'm just going to keep doing that. And then I'm going to go backwards, down 1, left 2, down 1, left 2. I'm doing the opposite. This is going to be a solid line. And then I'm going to be shading less than, because this one is a less than or equal to. So I'm going to be shading less than. And so I'm going to be shading everything underneath here. So the line is solid. So everything on the line is a solution. And then everything underneath is going to make that true. And again, why am I shading below? Because that inequality right there, that inequality is saying that it is less than. And so that means that I want y is less than, which means shade below. Okay, on number 8, this one is in y form, so I can just graph it. So my y-intercept is 3, so I'm going to start at 3. Now you want to be careful with your slope. Your slope is a -2, put it over 1. If it's not a fraction, put it over 1. Because it's negative, instead of going up, I'm going to go down. Okay, so I am going to go down 2, and then I'm going to go right 1. So down 2, right 1, down 2, right 1, and I'm going to keep doing that. You want to continue your line off your graph. This is going to be a solid line. So I'm going to draw a solid line. And then if I look back at the inequality, it is greater than or equal to, so I'm going to shade above. Okay, so I'm going to shade above. Whoops. And so I'm shading everything here. Now, in this case, everything on the line is a solution because it's a solid line, and everything in the shaded region. On number 9, this is going to be a system, so I'm going to be graphing 2 inequalities. Let's say I do the first one in, let's say, blue, and I do the second one in red. Okay, so if I'm doing the first one in blue, my y-intercept is going to be a 2. And then again, let me just jot this up here. My slope is a 3/5, which means I'm going to go up 3, right 5. So I'm going to go up 1, 2, 3, right 1, 2, 3, 4, 5. And then I'm going to do the same but going backwards. So down 3, left 1, 2, 3, 4, 5. This is a dashed line. For this one, if I'm looking at this, this is less than or equal to. So I want to shade y's that are less than or under. Now, the line is a dashed line, so points on the line are actually not a solution. They're only a solution if it's on the solid line or in the shaded region. Now, the second one is not in y equal form or y form, so I'm going to minus 3x. I'm going to minus 3x. I'm going to get 6y is still greater than or equal to, I'm going to write it as a negative 3x plus 12. I'm going to divide by 6, divide by 6, divide by 6. So I'm going to get y is greater than or equal to negative 1/2 x plus 2. So my y-intercept is 2, so they share that. But now since my slope is a negative 1/2, I'm going to go down 1, right 2. So I'm going to go down 1, right 2. And then up 1, backward, left 2. And this one, if I'm looking at it, is going to be a solid line. Okay, so solid line. And then I'm going to be shading everything. Whoops. I'm going to be shading everything that is, because it's greater than, above the line. And so that's going to be everything here. So let me just start at the line. So as I'm going through here, you can see that some sections I had both colors, and some sections I have one color, and some sections I have no color. So where my answer is, I'm going to write the word answer. Okay, this is where my answer is, any point in this region, which includes stuff that is from here to here on that line. Not over here though, because there's no blue over here. And that line is solid. Over here, this line, not included because it's dashed. Okay, just understand that. So on this problem, we are asked to write the system of inequalities, which we call constraints. It's where we have maybe some restrictions, some limitations, some requirements for the following situation. John is doing a fundraiser for school. He needs to sell at least $200 worth of items. Shirts cost $10 each. Hats cost $8 each. He must sell more than 12 hats. So some of the information that I need, he needs to sell at least $200 worth of items. That's going to be important. And we know that it costs $10 for each shirt, and hats are $8. We have another requirement, and that requirement is that he must sell more than 12 hats. Okay, so those are our situations. So for this, let me just get a text box. I'm going to type this up. And let me just make this a little bigger. Okay, so for this, I'm going to let S equal number of shirts and H equal number of hats. And then for my first inequality, okay, I'll do that in my red will be like what my pink is. Okay. So when it says he has to sell at least $200 worth of items, what that means is he is going to have greater than, at least, sorry, less, greater than or equal to, I'm saying one and I'm typing the other, greater than or equal to 200, okay? Because he has to sell at least $200. So $200 or more. And when he's doing this, each of his shirts, which he has S shirts, cost $10. So that's going to be 10S. Plus each of his hats, which he has H of them, cost $8. So 8S, H. So that is going to be his having to sell at least, which means $200 minimum or more. So I've got the equal. Now for the hats, okay, he has to sell more than 12 hats. So that means greater than, strictly greater than 12, not equal to 12, because he has to sell not at least 12, but more than 12. And that would be our inequalities. And we don't have to solve it. That's it. We're done. To describe each of these pieces here. And so for this, so what is the difference in solutions between A, B, and C? So on this, let me start by talking about the section in white. So this section right here, B, these points do not satisfy either inequality. Do not satisfy either inequality. In this section here, satisfy only I'm going to say the linear, because it's the line, it's the blue line, satisfy only the linear inequality. Okay, doesn't satisfy both. Down here, satisfy only the red one, which is the exponential inequality. So all of these ones that I talked about so far, none of them is the solution. The solution is over here in D. So this is where our solutions are, because these satisfy both. Satisfy both inequalities. And that's what we're looking for when we're doing this. On 12, we want to sketch a graph of this. And when we sketch a graph, we want to be very precise with a couple of things. Number one, this 5 is going to be our y-intercept. So I'm just going to, I can put a point here and just say it's 5. And then I also want to look at this, and I know that these absolute value graphs have asymptotes. For us, it's going to be on the x-axis, so that equation is y equals 0. And the way we spell asymptote, A-S-Y-M-P-T-O-T-E. So that's our asymptote there. Then we also need to decide if this is an increasing or a decreasing exponential. And because that multiplier is less than 1, it's going to be decreasing. So I'm going to be starting up here. It's going to be coming down through, getting closer and closer and closer to that asymptote, but not crossing it. On 13, we're solving this systems of equations. So we are going to try to eliminate one of these variables. So my x's, I have a 3x and a 5x. That's not going to be as easy to get rid of. I'd have to try to get a 15 in front of both of them, With my y's, I have a y and a 3y. I could try to make the top one into a negative 3y, and then they can cancel out. And I think that's what I'm going to do. So I'm going to multiply the top equation by negative 3. And so I'm going to get a negative 9x minus 3y equals a negative 18. My second equation is going to stay as a 5x plus 3y equals 2. I'm going to add these two equations together. My y's are going to cancel out, and I get a negative 4x is equal to a negative 16. I divide by a negative 4, and I get x is equal to 4. That's one of our solutions. We need to find an x and a y. So I personally am going to take this and substitute it into that equation to find my y. So I am going to go 3 times 4 plus y equals 6. So 12 plus y is equal to 6. I'm going to minus 12 from both sides, and I get a negative 6. We always write these as points because these are points of intersection. So I always write my x and then my y. That's always how I write them. So this is going to be 4 comma negative 6. That is our solution. That is our point of intersection. On 14, a couple things I'm going to deal with. I don't like that negative exponent. I don't like that negative exponent. And then I'm going to have to do something with this. So let me do a couple of things. Let me first deal with my negative exponents. So I'm going to have a y to the 4th on top. Let me deal with the 2x to the power 3 in a second. The x to the negative 6 from the top is going to move to the bottom, and now it's going to be a positive. The y to the negative 2nd from the bottom is going to move to the top, and now it's a positive. Now I still need to deal with this. Whoops. And this is 2x being raised to the 3rd. So when I'm dealing with that, I have a y to the 4th and a y to the 2nd, which I'm going to clean up. But right now I'm going to focus on that 2x to the 3rd, and that's going to be an 8x to the 3rd because my 2 is being raised to the 3rd, and so is the x. And then I have an x to the 6th. Now I need to clean up my y's and my x's. So on top, I'm going to have a y to the 6th. On bottom, I'm going to have an 8 and an x to the 9th. And that is our answer. On 15, I want to find the equation of the line that goes through these 2 points. So an equation of a line is y equal mx plus b. Now, in this situation, that is our y-intercept. 0 comma any number is a y-intercept. So I know I'm going to have y equal mx minus 7. And again, that is because this is going to go right there. Now, what I'm going to do is I'm going to put this point here in for my x and y so I can find my m. So I'm going to get 3 is equal to m times 5 minus 7. So I'm going to get 3 is equal to 5m minus 7. I'm going to add 7 to both sides, and I get 10 is equal to 5m, divide by 5, and my m is 2. So now my equation is going to be y equal 2x minus 7. And that's my equation. On 16, I'm looking at this triangle, these 2 triangles on my side, if they're congruent, and then if so, by what. So when I'm looking at this, this angle here, let me do it and not the highlight, I want this. This angle here and I'm just going to add a little tick mark there. And this angle here, those angles are the same. This angle here, which has the double mark, and this angle here are the same. So right now I have two angles that are the same. And then this line right here is a side that's the same in both. Okay, so those are going to be congruent in both. So looking at this, you care about the order. This is angle. I'm going to start this way. This is angle, angle, side. And on the other side, I also have angle, angle, side. Okay, so you want them the same on both. So the answer to this, are these congruent? Yes, they're congruent. Reason, angle, angle, side, congruency. And then if we have triangle O and P, we have to look and see what goes with O, and that is Q. What goes with N happens to be N, but it's not always the same letter, and then P. And that's the end of this video.